Welcome to another episode of Astronomy Daily, your go-to source for all the latest in space and astronomy news. I'm your host, Anna, and today we have a thrilling lineup of stories ranging from rocket launches to cosmic discoveries. In today's episode, we'll be covering the successful launch of ESA's Earthcare mission aboard a Falcon 9 rocket, the reentry of Russia's Progress 86 cargo spacecraft, and a fascinating update on a planet thought to exist in the Star Trek universe. We'll also explore whether the Milky Way orbits anything, discuss NASA's OSiRIS Apex mission as it bravely passed close to the sun, and look at the recent test success of the Vega C rocket's engine as it nears a return to flight. So buckle up and get ready for an exciting journey through the cosmos.
The Astronomy Daily Podcast.
The Earthcare mission, led by the European Space Agency ESA and the Japanese Aerospace Exploration Agency JAXA, successfully launched atop a Falcon 9 rocket from Vandenberg Space Force Base. The launch took place on May 28th, marking another milestone in ESA's ongoing, if temporary, reliance on SpaceX for space access. The mission, officially named the Earth Cloud Aerosol and Radiation Explorer, Earthcare, is designed to study clouds and aerosols in the Earth's atmosphere. Earthcare aims to provide vital data that will enhance atmospheric science, particularly in the realms of climate modeling and weather prediction. The spacecraft carries a suite of instruments, including a cloud profiling radar provided by JAXA that will measure reflected sunlight and radiated heat across different atmospheric layers. This data is crucial for understanding the thermal balance of the Earth and the roles that clouds and aerosols play in it. The 2,200-kilogram spacecraft is now in a sun-synchronous orbit at an altitude of 393 kilometers, where it will collect and analyze atmospheric data. This collaborative mission exemplifies the international effort and scientific dedication aimed at addressing some of the most complex environmental challenges facing our planet today. As ESA waits for the Eredani 6 to become operational, currently scheduled for its first launch in July, the Falcon 9 serves as a reliable interim solution for getting critical missions like Earthcare into space. The uncrewed Russian Progress 86 spacecraft has completed its latest mission by undocking from the International Space Station and re-entering Earth's atmosphere, where it burned up over the Pacific Ocean as planned. Progress 86, launched atop a Russian Soyuz rocket from the Baikonur Cosmodrome in Kazakhstan on December 1, 2023, played a crucial role in delivering 5,600 pounds of food, scientific hardware, and other necessary supplies to the astronauts aboard the ISS. Serving a dual purpose, the spacecraft also acted as a garbage truck in its final hours, hauling down trash from the orbiting lab for safe incineration in Earth's atmosphere. This approach to space waste management ensures that the orbiting environment around our planet remains free of debris. Although Progress 86's mission has come to a fiery end, the space station remains well supplied with 4 other operational spacecraft, including SpaceX's Crew 8 Dragon capsule, a Russian Soyuz crew spacecraft, the Progress 87 freighter, and a Northrop Grumman Cygnus cargo vehicle. This ongoing cycle of supply missions highlights the complex and continuous logistics that keep the ISS operational and its astronauts supported. New precision measurements have debunked the long-believed existence of a planet orbiting the star 40 Eredani A, famously known as Vulcan, the home planet of Mr. Spock in the Star Trek universe. This groundbreaking revelation comes from a recent study that clarified the possible detection as an astronomical illusion, brought about by the natural pulses and jitters of the star itself. Initially thought to be a super-Earth in a close 42-day orbit around 40 Eredani A, Vulcan's existence had ignited excitement when first announced in 2018. However, the new high-precision data, obtained from a sophisticated NASA NSF instrument at Kitt Peak National Observatory, has shown that what appeared to be a planetary signal was in fact the result of stellar activity. This highlights an ongoing challenge in exoplanet detection, particularly when using the radial velocity method. Scientists found that the star's surface features, combined with internal motions, mimicked the signals they normally attribute to orbiting planets. While disappointing for Star Trek aficionados, this finding underscores the importance of continued advancements in observational techniques, which will help astronomers distinguish more accurately between planets and stellar phenomena. Next, let's delve into a fascinating question. Does the Milky Way orbit anything? It turns out that not everything in the universe follows the same straightforward orbital paths like planets around stars. The Milky Way, our home galaxy, along with its neighbor Andromeda, actually orbits a common center of mass within a collection of galaxies known as the local group. Astronomers explain that because the masses of the Milky Way and Andromeda are comparable, the common center of mass lies between the two galaxies. This dynamic gravitational interaction means that both galaxies are mutually pulling towards each other, leading to an eventual cosmic collision. This collision, expected to happen in about 4.5 billion years, will cause the Milky Way and Andromeda to merge, forming a massive new elliptical galaxy. Moreover, the local group is not standing still. It's moving towards the Virgo cluster, a much larger conglomeration of several hundred galaxies. However, due to the ongoing expansion of the universe, our local group will never reach the Virgo cluster. This expansion is pulling galaxies apart faster than their mutual gravitational forces can draw them together. So, while the Milky Way doesn't orbit a single larger object, it's engaged in a complex dance with Andromeda and other members of the local group, all while being swept along by the broader currents of the universe's expansion. NASA's OSiRIS Apex spacecraft has emerged unscathed from its closest ever pass by the Sun, putting any concerns to rest. Mission engineers had high hopes, and their confidence wasn't misplaced. The spacecraft, designed to withstand such harsh conditions, was positioned ingeniously to shield its sensitive components, proving its resilience and excellent engineering. During the perihelion on January 2, 2024, OSiRIS Apex got within 25 million miles of the Sun, much closer than initially intended for its design. This close encounter tested the spacecraft's limits but also revealed some unexpected benefits. Sensors and instruments functioned better than anticipated after exposure to high temperatures, with one camera seeing a significant reduction in hot pixels, thanks to a natural annealing process from the intense heat. Now, fully operational, OSiRIS Apex is on a path to rendezvous with asteroid Apophis in 2029. The mission includes navigating multiple close passes by the Sun and leveraging 3 Earth gravity assists to adjust its trajectory. While the spacecraft's stellar performance so far is encouraging, engineers remain vigilant about the cumulative effects of these intense perihelion passes. The Zefiro 40 solid rocket motor passed a critical test at Avio's facility in Italy, making significant progress towards the return to flight for the Vega C launcher. This test is crucial in confirming the motor's improved engine nozzle design, which is necessary for Vega C's operational return by the end of 2024. The Zefiro 40, a 7.6-meter-tall rocket motor loaded with over 36 tons of solid propellant, performed as expected throughout its 94-second burn duration. Vega C is the upgraded version of the original Vega rocket, which has been operating since 2012. Designed to take over from its predecessor, Vega C promises enhanced capabilities for European space missions. The European Space Agency, ESA, oversees the Vega C program, ensuring its qualification and purchasing launch services for European institutional missions. Avio is the prime contractor and design authority for Vega C, while Eredani Space will provide the launch services. A second firing test of the Zefiro 40 motor is scheduled for October 2024 to validate the data collected and ensure the rocket's readiness. With successful tests, Vega C will replace the older Vega model and bolster Europe's presence and capabilities in space exploration and satellite deployment. That's a wrap for today's episode of Astronomy Daily. I'm Anna, and thank you for joining us. We hope you enjoyed this fascinating journey through the latest space and astronomy news. As always, there's much more to explore, so be sure to visit our website at astronomydaily.io. There, you can stay updated with the latest stories, listen to back episodes, and dive into exclusive content from our sponsors, including NordPass, NordVPN, Proton Mail, and Amazon. Do you want to support our show and get more exclusive content? Head over to our Become a Member page on our website. Your support is invaluable and helps us continue bringing you the best in space news. Have a wonderful day and keep looking up at the stars.